make sure you do it before, okay? All right. Okay, let's go over page 2. All right, I'm gonna keep going over certain things because some of us aren't really studying like we need to, and your quarter test and your end of year test is going to be on this stuff. What do you need, babe? You have to come to the table and get it, okay? All right, so we got linear versus exponential. All right, linear. What kinds of lines do linear functions graph? Noah, what type of line does a linear function graph? Straight lines. What kind of lines do exponential functions? Allie, what kind of lines do exponential functions graph? Curved lines. Okay. What is the form that an exponential function is written in? What's that form? What's the standard form for exponential function? Savannah? Mhm. Y equals a times b to the x power. How do we know that an exponential function is exponential growth? How do we know it's exponential growth, Sierra? B is greater than 1. How do we know that it's decay, that it's exponential decay? James? B is less than 1. Okay. What kind of sequence is a linear function? What kind of sequence is a linear function, Tan? What kind of sequence is a linear function? What kind of sequence is a linear function, Genesis? Lyric? What kind of sequence is a linear function? Go ahead. What do you think? Nope. That is the slope intercept form. What kind of sequence is a linear function? Lyric? Arithmetic sequence. What kind of sequence is a exponential function in? Geometric sequence. Okay, geometric sequence. What are the two ways that an exponential function can be graphed? What are the two ways that an exponential function can be graphed? Madison, can you open the door? Mason, what are the two ways that you graph an exponential function? Genesis? That's one way to create a function table. What's the second way to graph an exponential function? Nathaniel? Use the graphic calculator. Okay. All right. So now we are on recursive and explicit. Recursive formulas are formulas. They are formulas where you use the previous number to get the next number. An example is a next now equation. I'm gonna pause so that to make sure that you have this written. We wrote it yesterday, but a couple people, it was at the end of a lesson, so I'll make sure that you have it written. Okay, good folks. So let's do some examples. If I have an exponential function, and let's start with, pencil is red. Let's do a really easy sequence. We're doing geometric. Let's start with a small number like 4, okay? And let's multiply by 3 every single time. So my zero number, move it out to the side. We start with 4 and let's multiply by 3. So what's 4 times 3? What's 4 times 3? 12. Use a calculator if you don't know. What's 12 times 3? 30. Okay. What's 36 times 3? Type it in. What's 100 what? I can't hear you. Some people saying 120. Some people saying 108. 108. Okay. And what's 108 times 3? Okay, so now this is my zero number. This is my first number. This is my second number. This is my third. This is my fourth. These numbers are just my X values. That just tells me this domain. This is my output for my starting number, my output for my first number. This is my output for my second number, my output for my third number, my output for my fourth number. How would I write this as a next now equation? The first thing that I do is write starting at. What number am I starting at? 4. I'm starting at 4. Now I write or use the words next equals now. So my next number is equal to whatever my current or my now is. And what am I doing to get to the next number? Multiplying by, say again, baby. Multiplying by 3. So we're going to use the dot for multiplication. 3. This is a next now equation. I have to use the previous number to get the next number. Any questions about that? Another way to write a recursive formula. These are examples of recursive formula. Next now is not the only way to write a recursive formula. You could write it as a sub n, or you can use another letter. It doesn't matter. I'm going to just use a sub n because they use that often. And I can make it equal to, I'm going to start with the first number. And I'm going to multiply that first number times 3. Or multiply each number. And let me not use times because it looks like an X. Let's do parentheses. This is a next now. And sometimes they will tell you that the first number, the a sub n or the first number is equal to, and my first number is really 12. A sub 1 is really 12. What's a sub 0? 4. Okay. This is another way to write a recursive. You can't just substitute a number to get the direct answer. You have to use the previous number to get the next number. That's what makes it recursive. Let's do another example and see if you can write a next now equation for this. Let me do one real quickly. Where's my calculator? All right, so let's do this one. Let's start with this number. Let's make this our zero number. All right, so write a next now equation for this example here. I'm going to pause for the cause. And this is a geometric sequence, which means it is also an exponential function. Bless you. Okay, let's do it. This is my zero number. This is my output for my starting number. My output for my first number. My output for my second number. Ooh, Jesus, take the wheel. My output for my third and my output for my fourth. Okay. All right. So now, what are we starting with? Let's write the next now equation. We're starting at what number? 3. Okay. And we're going to write the words next equals now. And what are we going to write after that? We're multiplying by 4 to get to the next number. So I'm going to use the dot for multiplication. This is a recursive formula because you have to use the previous number to get the next numbers. So my next number is going to be 3 times 4, which is 12. Then the new number is 12. Plug 12 in. 12 times 4 gives me 48. Then plug the new number in, 48, and you have 48 times 4 gives you 192, and so on and so forth. Okay. All right, let's do let's write another equation. Instead of using a sub n, I'm going to use t sub x, okay? Because you don't have to use a sub n. It's just the popular one to use. If you use a sub n, you can keep it. I'm just using a different letter. So if I use this different letter, I have a t sub x. So now I have is equal to, and I'm going to use the first number. So I'm going to say t sub 1. Or I could put t sub 0. Doesn't matter, okay? If I put t sub 0 times, what am I going to multiply every single time? I'm going to multiply 4. And sometimes they'll put, instead of putting this, they might put x minus 1 or n minus 1, okay? That's fine. That means they're starting with the first number and not the 0 number, okay? And the other thing they have to tell you is what number to substitute in first. So the number that we're going to substitute first is the t sub 1. What's t sub 1 in this case equal to? It's 12. Okay, this is another recursive formula because I can't just substitute 1 and get an answer. I can't just substitute 2 and get 48. I can't just substitute 3 and get 192. I have to use the first number or the previous number to get the next numbers. So I put in 12 and I say 12 times 4, that gives me 48. Then I take the 48 and plug in 48. 48 times 4 gives me the next number. Then I take this next number, plug it in to get the next number. That's what recursive formulas do. I can't just substitute 3 and get 192. That's how I know it's recursive and not explicit. Any questions about recursive? So now we're going to do explicit. Anyone still writing? So let's do explicit. Explicit formulas are formulas where you can substitute a value to get your answer, okay? Or to get an output. Substitute where you can substitute the number that you're looking for and get an answer. And you can say, be fancy and say you can get an answer, get an output. But that's when you can substitute the target you're looking for. If I'm looking for the 5th number in the list, I should be able to plug in 5 and get an answer. If I'm looking for the 100th number in the list, I should be able to plug in 100 and get the answer. All right, let's do it, y'all. Okay, so with explicit, let's use this example. Let's go back to the other table that we had. There we go. All right, so we have 4, we got 12, 36, 108, and 324. We go back to the same example that we used earlier, okay? We're not writing explicit for this one. We're not writing recursive this time. We're going to do explicit, okay? So an example of an explicit, first, I'm going to do this again. This is my 0 number. And again, this is a geometric sequence because you're multiplying to get to the next number. If it's a geometric sequence, that means it's an exponential function. So this is my starting number. That's why I have 0 as my domain. This is my first number in the list, my second number, my third, and my fourth. This is my domain. This just tells me what term it is. My 0 term, my first output, my second output, my third output, and my fourth output. Any questions? Okay, we're going to write the equation in standard form for linear functions. The standard form for a linear function is an explicit formula. So we got the standard form. for exponential function. The standard form for exponential function is a times b to the x power. Slide this over. What is the a? What is the a? The y-intercept, or the starting amount. Very good, babe. What is the b? The common ratio. Very good. All right, so in this example here, what's going to be my a? What's my a in this example? What's my starting amount? My starting amount, or my zero number, is 4. That's the starting amount right here. What's the common ratio?
3.
It's 3. I'm multiplying by 3 to get the next number. So then how do I write the explicit formula for this example? Y equals 4 times 3 to the x power. This is the explicit formula. Why, Ms. Reyes, is this the explicit formula? Because if I'm looking for the 5th number in the list, I can plug in 5 for x and get my output. If I'm looking for the 100th number in the list, I can plug in 100 for x and get my answer. That's what makes this explicit. I'm going to pause for the calls. All right, here we go. Let's do a next now for this one. No, recursive. Right, it's recursive. All right, so let's do the geometric sequence. Geometric sequence formula is another explicit formula, okay? It's a sub n, the term that you're looking for, is equal to a sub 1 times the common ratio raised to the n minus 1 power. This is the formula for a geometric sequence. Drinking water in my business. All right, so this right here is the term you're looking for. This is the first number in the list, not the 0 number, but the first number. And then again, this n again is the term you're looking for. And I'm going to pause to give you a chance to write. The R, I forgot, is your common ratio. Sorry. And then, Jemiah, this is N. This is the number that you're looking for. All right, good deal. Okay, so this is how you write the geometric sequence formula for this. Same way, you got a sub n, the term that whatever term you're looking for is equal to. You got your first number. Your first number is really 12 here. Times, what's the common ratio here? Say again. 3. And to the n minus 1. Okay. You can use this formula to plug in the number you're looking for. You're looking for the 100th number, put in 100 here, put in 100 here, and solve. You'll get your answer. If you're looking for the 10th number, put in 10 for n and get your answer. If you're looking for the 50th number, put in 50 here, simplify and get your answer. Okay? You don't have to use the previous number to get the next number. You substitute and solve. Any questions? See if you can do this one on your own. See if you can do that one. Pause for the cause. You're going to use this formula right here, the standard form for exponential functions, and then you're going to use the geometric sequence formula. Write them both. The standard form, I'll write it here for you so you'll know. You're going to write the standard form for exponential functions. And then you're going to also use the geometric sequence formula. Okay. You're going to do both. All right, here we go. All right, what did you get for the standard form for exponential functions? What's your A and then what's your B? My A is 3. That's my zero number. What's my B? It's 4. I'm multiplying. My common ratio is 4. So then how do I write the equation? To the x power. How'd I get what? 4? What? Think about, go backwards and say 12 divided by 3. Just go backwards. Yeah, you can work backwards. If you're trying to figure out what you're multiplying, then divide. Go backwards. 12 divided by 3. That gives you 4. Or 48 divided by 12. That gives you, just work backwards. All right. Geometric sequence. So we got a sub n. We already know that. What's the common ratio? What's my r? 4. My r is 4. What's my a sub 1? 12. It's 12. That's the first number in the list. So we have 12. Oh, maybe I should write the formula. It's times r to the n minus 1. Okay? So that's a sub n is equal to 12 times 4 to the n minus 1. Got it? Oh, they're not hating. Are you hating? Okay. So we're going to find the nth term by using the formula. Why do I keep picking up the wrong pencil? A sub n is equal to a sub 1 times r to the n minus 1. All right, so look. When you're doing these lists, automatically assume that they're giving you the first number. They're not giving you the zero number. They're giving you the first. Unless they tell you that it's the zero number. It's when they give you a list, it's automatically the first number. So this is the first number. This is the second. This is the third. Automatically assume, unless they tell you that this is the first number, the second number, the third. Automatically assume that they are giving you the first number unless they tell you that it's the zero number. So this is the first number, the second number, and the third. Questions about what Ms. Reyes is saying? That's the one that I'm going to do. I'm going to do number 1. If we feel comfortable, I'm going to let you do the others. If you don't feel comfortable, then I'm going to do number 2, and so on and so forth. So watch me do number 1, please, so that you have less questions. No writing, just watch. All right, I'm going to rewrite the formula for each of these because I don't know the formula by heart. I do, you don't, okay? So we got a sub n, we got a2, a sub 1 times the common ratio raised to the n minus 1. All right, so the term that I'm looking for is the 10th number. So I'm going to replace n with 10. I'm looking for the 10th number. The first number here is 5. The common ratio, what am I multiplying to get the next number? I'm multiplying -3. So my common ratio here is a -3. So I'm going to substitute -3 here. I'm going to put here 10. So I got 10 minus the 1. So I'm going to solve to find the 10th number in the list by simplifying this. Okay? We can actually type this. Let me see your calculator. We can type this in our calculator, actually. No writing yet, please. So we can, just to make sure you understand what you're doing before you write. So here we have 5. We got times -3. Caret key. This caret key here. And then this is going to be what? 9. Now I can press enter. See what that gives me? That's a negative 98,415. This is the 10th number in the list. Any questions about that one? Please write it. Do you need me to do number 2, or you think you can handle it? Anybody, raise your hand if you want me to do 2. Okay. Pause for the calls. Write this down. I'll do number 2. All right, number 2. Let's look at it. All right, so we're going to rewrite the formula. This one you can kind of write with me. This one you can kind of write with me. Need more lead. I'll be. Matter of what? You can make somebody mad by just saying, you mad? You mad? Like, what am I mad about? It's implying that I look like I'm mad. Do I look like I'm mad? I'm good, baby. All right. Thank you for caring. All right, so I'm going to rewrite the formula, and we're going to keep rewriting it so we can learn it, okay? All right, so what are we going to substitute for n? What is the term that we're looking for? The 9th term. So we got a sub 9. Any questions about why I'm writing a sub 9? What's a sub 1 in this problem? 18. 18 is the first number. Unless they tell you it's the 0 number, only assume that it's the first. Now we're going to write multiplication times by using the dot. What's the common ratio? What's being multiplied to get the next number? 2. So we got 2. Or you can put it in parentheses. And again, the n is 9. So we got 9 minus 1. What's 9 minus 1? 8. So we can go ahead and put 8 here. Any questions about how I got 8? Okay. All right. Calc again, baby. Thank you. So let's type this in. What are my keystrokes gonna be? What am I typing in first? 18. I got 18. Then what? Times 2. Then what? Caret key. Then what? 8. Okay. And this is going to give us 4,608. Because that's a part of formulas times the common ratio. I forgot what I wrote again. What was it? 4,608. Okay, thank you. 8. So the 9th number is 4,608. Yes, baby. Yes, if you know what you're doing, keep going. Anybody need to see number 3? All right, so I need you to try it on your own, please. Okay, I'm going to pause, give you a chance to do that. Because some of y'all's answers are puzzling, okay? So let's see what's going on. All right, let's rewrite the formula. A sub n is equal to the first number in the list times the common ratio to the n minus 1 power. Okay, what's the n? What number are you looking for? I'm going to write that out to the side. You're looking for the 8th number. What is the common ratio here? It's -2. You're multiplying by -2. Okay, to get the next number. All right. Any questions so far? Let's substitute. Oh, I forgot. What's a sub 1, the first number in the list? It's -3. So now let's substitute. Maybe it'll help if I write this out to the side. So now I have a sub n. My n is 8. I'm looking for the 8th number in the list. Equals -3 times, what's my common ratio? -2 raised to the what?
8 minus 1.
What's 8 minus 1?
7.
Is it okay that I put 7 or you need to put 8 minus 1? Okay. All right, so now we got a sub 8. So let's type it in. You like, get your own, Miss Reyes. I'm sorry. All right, so look, we're going to type in -3 first. Then we got times -2, caret key what? 7. Got it? And this gives us 300 what?
84.
Raise your hand if you got that right. 384. Good job. Okay, Samaj, what happened, baby boo? What happened? Oh, how you type it in again, Nathaniel? So you're typing in, do you see right here? -3 is first. You got it? Parentheses, -2, or times, okay? You put that in parentheses. And then you're going to do caret key. Caret key is under the clear. Right here. This is caret key. That's your exponent button. And then my exponent is what? 7. That's what it should look like. Did you get it? Okay. Here you go. Okay. Y'all ready to do the next one? Can you do that one on your own? Try it on your own? Okay, good.